Hey, good morning folks. Welcome to another live stream with Montana Outdoor Science School. My name's Melanie. I'm one of the instructors with Moss. Today's topic is everything to do with fossils. I'm sure a lot of you, having lived in Montana especially, have seen fossils even just out on trails. I know Fairy Lake and the Sacagawea Trail near Bozeman is a really popular one that's got a lot of fossils on the way up. So is the one at Storm Castle Peak. There's a lot of fossils on the way up there as well. But before I get going too far, Moss is an organization, we're a nonprofit organization that tries to get kids excited about science, nature, and the outdoors. We do this through our school programs, we do this through our summer camp programs. We try to involve lots of science-based activities or get kids knowledgeable in meaningful science facts. We try to do games that are based around science or bring some kind of science aspect into it. Basically, we just try to get kids thinking like a little scientist. And so we do all kinds of fun things with that. One of the fun things we do, we get to go over fossils. We even have a summer camp called Fossil Fanatics. If y'all are a part of the summer camps this summer, you may already know a little bit about it, or if you've been in summer camps in the past, you may know a little bit about it. As usual, if you have any questions, please feel free to type them into the comment section. I'll try my best to keep looking at the comment section, try to stay up to date on those questions as they're coming. Or if you are yourself a paleontologist, somebody who studies fossils and digs them out of the earth, would love to hear your comments in the section if you have anything to add to the conversation. So I'm going to turn my camera around and we can get started here. So I've got my little pile of various artifacts. Not all of them are fossils, and I'm going to talk about those as I get there. This is one of my personal ones. I wonder if anybody can see what that looks like, if that looks like a familiar shape to any of you. I'll give you all a hint. It's got the little spiral aspect of it. I'll give you another hint. Something used to live inside of it. And as a third final hint, this used to be a seashell. So this used to be some kind of sea organism. This was its shell that became fossilized. The process of fossilization itself is literally organisms or anything that used to be alive turning to stone, literally turning into rock. And I'm going to go over that a little bit more in detail here momentarily. But I thought I'd give y'all the opportunity to check out that fun little fossil there. You can really see the spiral well right there. This is one of my personal fossils that I really love. I love putting that one out for folks to see. Here's another one. I always like to kind of just lay this on a table for students and say to them, all right, what does this look like? A lot of them will of course say rock, but as you start to look at it from various angles, doesn't that start to look more and more like some sort of nautical creature, some sort of ocean-based animal? And this is also a shell, and it's very, very heavy. If we were to, I meant to grab a shell actually, I meant to grab a seashell. If we were to compare this to a seashell of comparable size, roughly about the same, this is much, much heavier, and that's because it's literally turned into rock. It's literally turned into stone. So let's talk about how fossils become fossils. So essentially, you need to start off with something that is alive. In my little example here, I brought out one of my little Stegosaurus figurines, and essentially something has to die and start to decompose, but very critically, it needs to be buried by some sort of sediments. If you recall last time, we talked about sedimentary rocks as we were talking about the rock cycle, and in the rock cycle, we see that fossils are only in the sedimentary layers. If they become metamorphic, they get that heat, that pressure, they become smushed, heated up so that they become something else, the fossil is destroyed. If we get to an igneous rock, then it essentially turns back into molten magma or lava. So we destroy the fossil in that way too, or we see the fossil destroyed in that way too. But if it remains a sedimentary, in sedimentary layers, the animal that is now died and decomposed gets covered up by sediment. I was going to bring in my sand, or I was going to bring out my sand, but I'm not going to do this inside, so I won't bring in my sand. But imagine it gets covered up with sand, it gets compressed, it gets pushed down, and very slowly all the soft tissues begin to disappear. In some cases, very, very rare instances, soft tissues may become fossilized too. But the hard parts of an animal, usually its exoskeleton, its inside skeleton, its outer shell, will start to become replaced by minerals that are in the water and in the soil. Often we find that fossils are part of a sedimentary layer where water or oceans or seas have deposited more sediments on them. The water carries with it some kind of minerals inside of it. It could be various minerals. I don't think I could explain all the minerals that might be possible, but they will very slowly, over millions upon millions of years, start to take out the small particles of the actual creature, so the bone structure, the shell, whatever it may be, and start to replace it with those minerals until you get something that looks like that. That is also another seashell, and this used to be a living organism. Very slowly, those parts of the shell were replaced by minerals in water. Water doesn't have to be directly exposed to this fossil. It's not like it's sitting at the bottom of a lake and water washes over it. Water travels through rock, it travels through soil. You could almost imagine it as if water is traveling through a sponge. A sponge is a solid thing, but water very gradually will move through it. You can imagine it the same way in the earth. Rocks, debris, has water moving through it, and that water carries with it very microscopic materials, very small. We have a noise in the background. Sorry about that, everybody. Please, if you can't hear me, type that into the comment section. I'll put this on pause and I can go somewhere else where things are much more easier to hear. But as long as you guys can hear me, I'll just continue on. So that's how a fossil is made. Mineralization replaces the actual organic material of the animal or of the plant, and it very slowly becomes a fossil. So I showed you guys that little seashell there. I showed y'all that one there. I've also got this other pretty cool example. This one looks a little bit more like the fossil rock I showed y'all on last Friday. We've got limestone layers through here, and then you can see all of these little tiny organisms, all these pieces that are really prevalent that you can see really easily. That used to be an animal of some kind or a plant of some kind. These ones here, I think, are tube worms. Oh, that's a little blurry. Let me show y'all. There we go. That one there used to be some kind of tube worm. Now, what I've shown y'all so far is mostly water-based creatures, and that's because these rocks, they come from Montana, and Montana itself used to be an inland ocean. If you could imagine the whole of North America, it used to be just 2 strips of land instead of 1 giant continent. These strips of land had a sea, an ocean in the middle, and it was a very shallow ocean, which made it possible for a lot of sea life to develop. This sea life, as it died, as it decayed, would fall to the bottom, be covered by sediment, and very slowly over millions of years, those shells, those exoskeletons, those bones would be replaced by minerals that the water brought along with it. Ooh, there's a really good example. That's some kind of tube worm of a sort. Again, if there's any paleontologists watching, would love to hear your comments in the comment section if you know exactly what any of these fossils are. I'm very curious to know what the animals may be in here. Moving along though, I've got another really good example of a tube worm sort of feller. That one is a really good representation there. So different parts of the animal may be replaced first over time. I've got a really giant example of that. I'm going to pick up my phone so y'all will be able to see this. So this rock has all these little tubes sticking out of it because this used to be a part of a giant coral. The coral died, sediment filled in the areas between its little branches. If you could imagine the whole thing, it would have been massive. These little branches would have been poking out in all kinds of directions. Sediment filled in the spots between each of those branches. What we get left with is the broken off remnants of that coral. But taking a look in these little actual branches, notice that there's kind of a 2-part thing going on. The outside of that little branch has been replaced with one type of material, but the inside has been replaced with a different type of material. And that's because, like I said, different parts of an animal may be turned into minerals, or maybe mineralized, maybe turned into a fossil at different rates. Again, this kind of process takes millions upon millions of years, so you can imagine there's going to be different types of minerals flowing past these organisms and replacing them very, very slowly over time. It's how you get, I'll go back to my seashell here. It's how you get different colorations throughout a fossil too. You can see it's more tan over here, but on this side, it's got more of an orange color to it. I've got another really great example. Let me pull it out for y'all. And I wish I had, oh, I do actually. Great. So I said earlier how it's not just animals that get fossilized, it's also plants as well. I've got here, oops, a piece of wood that has become fossilized. And just notice right off the bat, as I placed it in front of the camera, look at the striations, the lines through this. That is just like a piece of wood you might find out in a forest as it's breaking apart, as it's decomposing. It looks like just the outside of a wood that you might find in nature, but it's been replaced by minerals. It's been turned into rock, literally turned into stone. I'll show y'all what it looks like on the inside. Pretty neat. And again, you see all those different colors throughout the fossil. That's very slowly, it's over time, those organic materials have slowly been replaced by various types of minerals, and so you end up having a different colored thing. You can see the outside's all one type of color. No doubt that was replaced first, and then you've got the inside that's very dark. It almost looks like agate, I want to say. I feel like there's quite a few things in the world that, when they fossilize, can turn into agate. I'm not sure if that's what this is here. Again, I'm not a geologist, I'm not a paleontologist. I can only say what I know, but it does look like an agate. I'd like to hear from folks who maybe are geologists or paleontologists. So that's that rock there. I've got an actual piece of wood here, and it's comparably the same size, but you can see those lines again. This thing has the same kind of structure roughly as that other piece of wood, but you can tell it's not a fossil, not just by it being made out of wood still, but the weight of it is far, far different. And I was going to show everybody kind of a really great example of this. I brought with me a scale. On my scale, I can measure things in ounces. Yes, there we go, ounces. There's 16 ounces in 1 pound. So if this thing goes over 16, then we know that it'll be a pound. Let me put it on 0. Have to set it just right. Oh, I hope it works. There we go. So now it's set to 0. Nothing's on it. It's totally weightless at this point. And I'll show you all what happens when we weigh just the wood. So the wood, it's roughly the same size as my fossil here, which is really important. They both occupy about the same volume. We can now test their density by showing what they weigh, what their mass is. So that's not very much at all. 10.6 ounces. So that's not quite a pound yet. That's maybe, what is it? That's a, oh man, I can't do math all of a sudden. That's roughly just over half of a pound is what this wood weighs. Now let's try it with our fossilized wood. Oh, I hope it doesn't outdo the scale. Yeehaw! Quick math. What's 80 divided by 16? That's how many pounds this is. The the fossilized wood here, much, much heavier, clearly. It's turned to stone. So I wanted to show you all that little demonstration there. I like to have students test density. They take the volume. They can get that by dunking it in water, seeing the difference in the water change, and then they'll take the mass by weighing it on a scale. If you divide the mass by the volume, you get the density, and you'll find that rocks are often super, super dense, and fossils are dense thus as well. Let's see. Oh, so today's kind of a quick one. As a last thing that I was going to show y'all, you can sort of practice doing a fossilization yourself at home. And it's not a perfect fossilization, it's just a quick little representation. It's going to go a lot faster than what a regular fossilization period would be, of course, but it goes a little something like this. If you have any extra sponges around the house, you can take your sponge and leave it out for just a sec, but then you'll need a Tupperware as well. Make some salt water. Salt is a type of mineral that can be dissolved in water readily, so take some water, dissolve some salt into it, and fill up your little tub. You don't have to put very much in there. You could fill it up to maybe just a centimeter, maybe 2 centimeters, not even an inch. You don't need a whole lot, but make it very, very salty water. Then you take your sponge, you just place it in there. You don't want to get it in there and try to soak up the water. You just want to place your sponge in there and then set this up outside. As the water begins to evaporate, I want you to hypothesize what might happen to the salt that was in that water. And this is a really good representation of how minerals attach onto organic material. If we pretended this sponge was like a bone, and actually it does look very much like a bone. It's got the holes, the pores, the divots. I have a bone in the background here. You can see it's got all kinds of little pores to it as well, especially in that region there. So a sponge, it pretends to be a bone in this experiment. You place it in the salt water, and as the water evaporates, something's going to happen to the salt, and it's going to change how this sponge looks. And that's exactly how the process of fossilization occurs. So I'm going to leave y'all with that as your last thing. This is a really fun experiment, and there's all kinds of fun things you can do with fossil activities online. A lot of them I can't show them here today just because they do take time. Part of the reason I'm not doing the sponge experiment right now, but there's so much fun stuff to be had with fossils. I know the Museum of the Rockies is going to be reopening again soon with modified hours and modified admissions. They have really wonderful materials there for fossils, and so check that out as they get to be open again. Check out the local trails around your neighborhood. See what kinds of fossils you may be able to find. Like I said, Fairy Lake and then Sacagawea Peak Trail have a ton of fossils on the way up to the actual peak in the basin just under Sacagawea. And then Storm Castle, I know, has also a ton of fossils on the way up to it as well. So thanks for joining us, everybody. I hope y'all enjoyed, hope y'all learned a little bit of something. Be sure to like us on Facebook, be sure to follow us on YouTube. Check out our videos coming out in the following weeks relating to GVLT and our nature discovery walks. I'm sorry, virtual discovery walks. Those are coming out every Monday. And then we will see y'all on Friday. Friday, we're going to be talking about scat, which will be fun. So see y'all on Friday at 11 a.m., everybody. Thanks.